Introduction: Metabolic crisis. In today's world, insulin resistance has become a widespread problem affecting millions of people. This condition has been linked to chronic metabolic diseases, including type 2 diabetes, heart disease, and obesity. In this video, we will explore the root causes of insulin resistance and discuss how to address this issue through dietary and lifestyle changes. By understanding the underlying causes of insulin resistance and metabolic disease, you can take control of your health and make informed decisions about your diet and lifestyle. This video will provide practical advice and actionable tips for improving mitochondrial health and managing insulin levels. Understanding insulin resistance. The role of insulin in the body. Insulin is a hormone produced by the pancreas that helps regulate blood sugar levels. When you eat carbohydrates, your body breaks them down into glucose, which enters the bloodstream. In response, your pancreas releases insulin to signal cells to take up glucose and use it for energy or store it as glycogen or fat. What causes insulin resistance? Insulin resistance occurs when cells don't respond well to insulin signals, leading to higher blood sugar levels and increased insulin production. Over time, this can cause chronic inflammation, oxidative stress, and damage to blood vessels, organs, and tissues. The connection to chronic metabolic diseases. Insulin resistance is a significant contributor to various chronic metabolic diseases, including type 2 diabetes, heart disease, non-alcoholic fatty liver disease (NAFLD), and obesity. As insulin resistance worsens, it can lead to more severe health complications and reduced quality of life. Mitochondrial dysfunction, the root of the problem. The function of mitochondria. Mitochondria are tiny organelles found within cells that generate energy in the form of adenosine triphosphate ATP. They play a crucial role in maintaining cellular health and function. How sugar damages mitochondria. Excessive sugar consumption, particularly fructose, can damage mitochondria by inhibiting enzymes necessary for their function. This leads to a decrease in energy production and an increase in reactive oxygen species ROS, causing oxidative stress and inflammation. The role of fructose and enzyme inhibition. Fructose is a simple sugar found in many foods, including fruits, honey, and high fructose corn syrup. Unlike glucose, fructose is metabolized primarily in the liver, where it can inhibit enzymes essential for mitochondrial function. Other factors affecting mitochondrial health. In addition to sugar consumption, other factors can impact mitochondrial health, including dietary fat quality, radiation exposure, environmental toxins, and nutrient deficiencies. Addressing these factors is crucial for improving mitochondrial function and reducing insulin resistance. Nutrition and mitochondrial health. Dietary fat quality. Not all fats are created equal. The quality of dietary fat can significantly impact mitochondrial health. Healthy fats, such as omega-3 fatty acids and monounsaturated fats, support mitochondrial function, while unhealthy fats, like trans fats and excess omega-6 fatty acids, can promote inflammation and oxidative stress. The impact of radiation on mitochondria. Exposure to radiation, whether from natural sources or human-made devices, can cause mitochondrial dysfunction by damaging their DNA and impairing energy production. Obesogens and environmental toxins. Obesogens are chemicals that disrupt the body's metabolism and promote weight gain. Common obesogens include air pollutants, pesticides, and certain plastics. These toxins can harm mitochondria and contribute to insulin resistance. Amino acids and vegan diets. Amino acids are the building blocks of proteins and play a vital role in cellular function, including mitochondrial health. Vegan diets may be low in certain amino acids, like tryptophan, which can impact mitochondrial function. The importance of fiber for gut health. Dietary fiber feeds the beneficial bacteria in the gut, maintaining a healthy gut barrier and reducing inflammation. A high-fiber diet can support mitochondrial health by promoting a healthy gut microbiome. Identifying and avoiding hidden sugars. Decoding food labels. Food labels can be confusing and misleading. Learn how to identify added sugars in ingredient lists and understand terms like natural flavors or fruit concentrate that may indicate hidden sugars. The dangers of processed foods. Processed foods often contain added sugars, unhealthy fats, and artificial ingredients that can harm mitochondrial health. Discover how to recognize and avoid these foods in your daily diet. Whole foods for optimal health. Eating a diet rich in whole, unprocessed foods is crucial for maintaining mitochondrial health and managing insulin levels. Learn about the benefits of whole foods and how to incorporate them into your daily meals. Rethinking dietary guidelines. Metabolic health versus nutrition science. Traditional nutrition science often focuses on individual nutrients or food groups rather than overall metabolic health. In this chapter, we will discuss the importance of prioritizing metabolic health over traditional food science. Managing insulin levels. Keeping insulin levels low is essential for preventing insulin resistance and promoting metabolic health. Learn how to limit sugar and refined carbohydrate intake to manage insulin levels effectively. The benefits of a pescatarian diet. A pescatarian diet, which includes fish and seafood, but excludes other meats, may be an ideal dietary pattern for overall health and mitochondrial function. Discover the benefits of this diet and how to implement it into your lifestyle. Fructose, the metabolic disruptor. Fructose inhibition of AMPK. AMP-activated protein kinase AMP is a cellular energy sensor that plays a crucial role in maintaining metabolic balance. Fructose can inhibit AMPK, disrupting cellular energy regulation and contributing to insulin resistance. Uric acid and fat burning. Fructose metabolism can increase uric acid levels, which inhibit fat burning and promote fat storage. Learn how to manage uric acid levels through dietary choices and lifestyle changes. Glucose versus fructose. A comparison. Although both are simple sugars, glucose and fructose have different metabolic effects on the body. This chapter will compare and contrast the two sugars and their impact on mitochondrial health. The protective role of fiber in fruit. Fruits contain fructose but also provide dietary fiber, which slows fructose absorption and mitigates its negative effects. Learn about the benefits of whole fruit over fruit juices and concentrates. Juicing and fructose absorption. Juicing removes the fiber from fruits and vegetables, increasing fructose absorption and its potential negative effects on mitochondrial health. Discover healthier alternatives to juicing for obtaining essential nutrients without the added sugar. Insulin, fat storage, and metabolic disease. The effects of added sugars and refined carbs. Added sugars and refined carbohydrates can spike insulin levels, leading to fat storage and increased risk of metabolic disease. Learn how to identify and avoid these dietary culprits to maintain metabolic health. High insulin causes fat storage and metabolic disease. Chronically elevated insulin levels promote fat storage and contribute to the development of metabolic diseases like obesity, type 2 diabetes, and heart disease. Discover strategies for managing insulin levels through diet and lifestyle changes. Fatty liver, a growing epidemic. Non-alcoholic fatty liver disease (NAFLD) is becoming increasingly common, driven in part by high sugar consumption. Learn about the connection between sugar, fatty liver, and insulin resistance, along with strategies for preventing and managing NAFLD. Saturated fats. Not all created equal. Saturated fats have been widely vilified in nutrition science, but not all saturated fats are created equal. This chapter will discuss the differences between various sources of saturated fats and their effects on mitochondrial health. Dairy saturated fat, a potential health ally. Recent research suggests that dairy-derived saturated fats may have beneficial effects on metabolic health. Learn about the unique properties of dairy fat and how to incorporate it into a healthy diet. Trans fats, the ultimate dietary enemy. Trans fats are artificially created fats that have been linked to a host of negative health outcomes, including inflammation, heart disease, and insulin resistance. Discover why trans fats should be avoided at all costs and how to identify them in food products. Omega-6 fats, the inflammation connection. Omega-6 fatty acids are essential for human health but can promote inflammation when consumed in excess. Learn about the sources of omega-6 fats, their impact on mitochondrial health, and how to maintain a healthy balance of omega-6 and omega-3 fats in your diet. Glycemic load, a better measure of insulin impact. The glycemic index is a common tool used to evaluate the effect of foods on blood sugar levels. However, glycemic load may be a more accurate measure of a food's insulin impact. The complexity of dietary fats. Saturated fats. Not all created equal. Saturated fats have been demonized in the past, but not all saturated fats are created equal. Some sources, like dairy products, may have health benefits, while others, like processed meats, can be detrimental to health. Dairy saturated fat, a potential health benefit. Recent research suggests that dairy-derived saturated fats may have health benefits, such as improving insulin sensitivity and reducing inflammation. Consuming moderate amounts of full-fat dairy products like yogurt and cheese may be beneficial for metabolic health. Trans fats, the unhealthy choice. Trans fats are artificially created fats found in some processed foods. They have been linked to increased inflammation, insulin resistance, and heart disease risk. Trans fats should be avoided for optimal health. Omega-6 fats and inflammation. Omega-6 fatty acids, primarily found in processed vegetable oils like corn and soybean oil, can promote inflammation when consumed in excess. Balancing omega-6 intake with omega-3 fatty acids from fish, flax seeds, or chia seeds can help reduce inflammation and support mitochondrial health. Glycemic load, a better indicator of insulin impact. Understanding glycemic load. Glycemic load (GL) considers both the glycemic index (G) of a food and the amount of carbohydrate it contains, providing a more accurate measure of a food's impact on blood sugar and insulin levels. Choosing low GL foods for better metabolic health. Focusing on low GL foods can help manage blood sugar levels, reduce insulin resistance, and improve overall metabolic health. Examples of low GL foods include non-starchy vegetables, whole grains, legumes, nuts, seeds, and lean proteins. Practical tips for implementing a low GL diet. To follow a low GL diet, prioritize whole, unprocessed foods, limit added sugars and refined carbohydrates, and practice portion control with high carbohydrate foods. Combining carbohydrates with protein, fat, or fiber can also help reduce their glycemic impact. By understanding the factors contributing to insulin resistance and implementing dietary and lifestyle changes to support mitochondrial health, you can take control of your metabolic health and reduce the risk of chronic metabolic diseases.